Hello, ladies and gentlemen. We're going to take as quickly as we can. We're going to go through the book problems for our Chapter 11 and 12 review. Keep in mind that the book problems only reflect the items that we learned in Chapter 12. For Chapter 11, remember that's the area and surface. The surface area and the volume of three-dimensional shapes. You'll be given the formulas. You just need to know how to apply them. So for the bookwork, problems 5 and 6 are extremely similar, so I'm only going to do problem 5, although there's something I want to talk about for problem 6 real quick. If I look at problem number 5 and I need to talk about the tangent, then I would say that the tangent is line L, and if I write it in cursive, that denotes line L. I don't need to do any other notation. I need to talk about the chords for this problem. So I can say that segment QS is a chord, and I can say that segment UV is a chord. Keep in mind the definition of a chord is a segment whose endpoints lie on the circle. So when it gets to the radii, I'm going to talk about segment PQ, and I'm going to talk about segment PS. Those are my two radii. The diameter. My diameter is segment QS. And then I'm going to talk about my secant. My secant is the line that goes through the circle at 2 points. So I'm going to say UV, and keep in mind that the notation for the secant is the double-headed arrow. So that's all the chords, the radii, the secants, the diameter, the tangent lines for problem number 5. Number 6 is relatively similar. The only thing that's different is a little bit of the notation. So if I talked about the secant for problem 6, if I talked about the tangent line for problem 6, I would say that the tangent line is LK, and it would have that double-headed arrow. And the one thing that I wanted to point out is on problem 5, I do not have a tangent point or the point of tangency. It can be referred to in either place or in either way. So if I asked about, or if I gave you problem 6, you would also have to identify that point K is my point of tangency. So that's the only other piece of information that we needed to discuss. All right, problem number 7. Given the measures of the following segments that are tangent to a circle, find each length. So I have segment AB is tangent to a circle, and segment BC measures 7x plus 4, and we need to find AB. All right, so I have AB and I have BC, which implies that this point right here is B, and I can say that this is A and this is C. It doesn't matter. I've got a circle. I've got two tangent lines, two segments that are tangent to the circle from the same external point. And the thing that I know about that is if they are tangent to the circle from the same external point, then I know that these two segments are congruent to each other. So I'm going to label AB as 9x minus 2, and I'm going to label BC as 7x plus 4. Those two things are congruent, so I will set them equal to each other. 9x minus 2 equals 7x plus 4. As always, I'm going to identify where I have the most x's and move everything to that side. So I'm going to subtract 7x from both sides. I have 2x minus 2 equals 4. Add 2. 2x equals 6. It does not ask me for the value of x. It wants to know how long each of the segments are, and I need to find AB for problem number 7. Doesn't necessarily matter where I plug that in because both of those segments are the same length. I'm going to take 3 and plug it in for x. So I'm going to have 9 times 3 minus 2. 9 times 3 is 27. 27 minus 2 is 25. We're not given any units, so AB equals 25. All right, I'm going to go through and erase all of that stuff. And it says EF is equal to 5y plus 32 and EG. So my common point outside the circle is E. So if I say this is EF and this is EG, and they are tangent to the circle from the same point, which means that these two segments are congruent to each other. Segment EF is 5y plus 32, and segment EG is 8 minus y. So I'm going to set those two things equal to each other. I identify where I have the most y's and get all the values on that side. So I'm going to add y to both sides. I have 6y plus 32 equals 8. That's negative 24. I'm going to divide both sides by 4. Y equals negative 4. Again, it doesn't ask me what y equals. It asks me what the value of EG is. It wants to know how long EG is. So I'm going to take negative 4 and I'm going to plug it in for that. So I have 8 minus negative 4. Well, that's the same as 8 plus 4. Therefore, EG is 12. So our final answers, AB is 25 and EG equals 12. Find each measure. We need to find the measure of arc KM. I'm going to come over here, and as I would suggest doing on your homework or on a quiz or test, make a mark, see what you know. So I'm going to go in and circle in that KM is that red arc. The one thing that I know, because I know that all vertical angles are congruent, so if I know that this is 51, I know this is 51. And if I know that central angle is 51 degrees, I know that this arc is 51 degrees. And honestly, I don't know if that 30 is telling me about this arc or that central angle, but I know that either way, because it's a central angle and it's arc, they're both congruent to each other. And I can say that my arc KM is equal to 30 plus 51, which is 81. We do arc measures in degrees, and we won't forget putting that degree sign on there. So now I need to think about the measure of HMK. So I'm going to start at H, go through M, and get to K. So now I'm going to think about the blue part of this arc. And I'm going to leave these numbers in here because it sure does help me to know that that's 30 and that's 51. Well, now I'm at a loss because I need to know what the measure of this is. And there's nothing really on there that gives me any kind of indication. However, that red circle in the middle, and I'm going to go over in green, this is a diameter. That red is a indicator that it's the center of the circle. So I've got supplementary angles. So this angle right here is 51. I'm going to call it, well, let's call it G. 51 plus G equals 180. So I'm going to subtract 51 from both sides. And I'm going to say G equals 129 degrees. All right. So if G equals 129 degrees, I can say that HMK equals 129 plus 51 plus 30. I suppose that what I really could have done is said, I know that this is 180 plus another 10 or another 30 gives me 210. So this whole angle or this whole arc is 210 degrees. All right, we need to figure out the measure of arc JK. All right, things are getting really cramped over here, so what I'm going to do is erase this, and I need to know the measure of arc JK. Well, the one thing that I know is the measure of this angle, this straight line is 180, so 30 plus this plus 51 should give me 180. So I'm going to say 51 plus x, well, I'm using x as that. JK is going to be x, plus 30 equals 180. 30 plus 51 is 81. I'm going to subtract 81 from both sides. X equals 99. In this particular case, I'm finding an arc measure. So JK is 99 degrees. Lastly, I need to find the measure of arc MJK. MJK. So MJK starts here and goes all the way around to there. Well, one of the things that we found out was we could take 360 and subtract this. And we said this was 51. We said this whole thing right here was 81. So if that whole thing is 81, I can say that MJK is 360 minus 81. And honestly, I just don't know what that is. 360 minus 81 gives me 279 degrees. Find each length to the nearest tenth. So we need to find ST on number 15. So I'm going to label this X and I'm going to label this X because one of the things that we said was if we have a chord that is cut at a perpendicular by a diameter, that it's also bisected. I'm going to draw in QT. What's the length of QT? Well, QR is a radius, QT is a radius, QR is 4 and 7, which makes the entire radius 11. Okay, so let's see what else we've got. I've got this triangle like this, and I'm going to move that down here. I know that this is 11. I know that this is 7. I know that this is a right angle. And let's make this a little bit bigger. Okay, so I'm going to use the Pythagorean theorem and find A. So I'm going to say A squared plus 7 squared equals 11 squared. This is 121. This is 49. All right. I'm going to subtract 49 from both sides. I'm going to go to my calculator because I just don't know. 121 minus 49 gives me 72. I'm going to take the square root of 72 because it says to the nearest tenth. So I don't need to simplify this in a radical form like we've had to do for some of the other ones. I'm going to take the square root of, my board calculator is being really weird and I apologize for that. So I'm going to take the square root of 72 and A is plus or minus 8.485. 8.485. And it says to round that to the nearest tenth. I'm going to look at the second digit in and decide what that does. So A is approximately 8.5, but I'm not looking for A, and I've got it marked as X up there. So this distance right here is 8.48, and this is 8.48. So the whole distance, so ST equals 2 times 8.48, and I'm going to round that in the next step. So I'm going to go to my calculator and say, I'm going to multiply the answer that's already in there by 2, and that gives me 16.97, and I'm glad, 16.97. It says to round to the nearest tenth. So I look at this, and that tells me what to do about this. 7 makes the 9 go up. The 9 makes the 6 go up. So this ends up being 17, but we're going to say 17.0 because that tells the viewer that I've considered more and I've rounded. All right, so segment ST is 17.0. For problem number 16, we have to find CD. All right. And again, okay. So on this, I need to find this entire length. And I know that I'm going to go with this as a right triangle and then double things. It's got some congruent markings. It says that that right there is congruent to that right there. If this is 2.5, then this is 2.5, which means the radius is 5. Okay, so that means I've got this triangle right here, and I'm going to make that a little bit bigger. Ooh, oh, and try not to distort it too badly. So that looks like a right triangle. So this is 90 degrees. This is 2.5. This is 5. And this is x. All right. Well, I've been beating this 30, 60, 90 triangle drum for a long time. This right here is a hypotenuse, and my spidey sense says that that hypotenuse is 2 times the length of the short leg. And if I know that the hypotenuse is 2 times the short leg, then I know that I have a 30, 60, 90 triangle. And if I know that I have a 30, 60, 90 triangle, that means without doing anything else, that this is 2.5 times the square root of 3. And if x is 2 times the square root of 3, then that means that this distance from C to D is 2 times 2.5 times the square root of 3. When I multiply anything with a radical in it, what's outside the radical stays outside the radical. What's under the radical stays under the radical. So 2 times 2.5, that's all stuff that's outside the radical. I'm going to multiply those two things together. 2 times 2.5 is 5. What's under the radical stays under the radical. My directions say to do this to the nearest tenth. I'm going to go to the calculator and say 5 times the square root of 3. And my calculator is going to be weird, and I'm going to go out and do this. So I get 8.66. So CD equals 8.66, which is approximately 8.7. You can absolutely do this using the Pythagorean theorem, but I feel like my method took a lot less keystrokes and a lot less time to do. All right, find the area of each sector, give your answer in terms of pi, and round it to the nearest hundredth. Well, let's start by reminding ourselves that the area of a sector, and remember a sector is, well, the official definition is 2 radii and the intercepted arc. It's the area of the space bounded by that. But think about, it's like a slice of pizza or a slice of pie. So the area of the sector is pi r squared. So we're finding the area of the circle, and then we're multiplying that just by the section that we need to know the area of. So it's m over 360. So I'm merely going to plug in what I need to know. So pi times 12 squared times m, which is 30 over 360. All right, so this is 144 pi, and then 3 over 360, I think that's going to be 1/12. So 3 divided by 36, I just want to reduce this. It's going to be 1/12. All right, I'm going to rearrange this. Now, in my head, I just want you guys to know in my defense, I'm not doing this in 27 steps. I'm writing all this down for your benefit so you can see where this comes from. But I'm going to slide 144 next to the 1/12 and then pi. So basically, I'm saying 144 over 12 times pi. Well, what's 144 divided by 12? It's 12 pi. So my answer asks for in terms of pi. The only thing that I need to do is come up and check about units. This does not have a unit on it, so my answer in terms of pi is 12 pi. My area in terms or to the nearest hundredth is, I'm going to come to my calculator and say 12 pi and hit enter. My nearest hundredth, 37.660,699. So 36.699. I'm going to look at my third digit, and that tells me what to do about my second digit. So I'm going to say my area is approximately 36, nope, because that 9 rounds that 9 rounds that to a 7, so we get 36.7 square units. All right, let's take a look at number 18. Number 18, we're going to use the same formula that the area is pi r squared times m over 360. Let's plug in what we know. Pi, my radius equals 1. What's 1 squared? 1 squared is 1. I'm not even going to bother writing it. I'm going to say 90 over 360. I look at that and I recognize 90 degrees in a circle. Well, there's 4 of those. So my answer is 1/4 pi, or pi over 4. This is meters, so I'm going to say meters squared. So that's one answer. My answer to the nearest hundredths, I'm going to come over to my calculator. I'm going to type in pi and divide that by 4. And my answer is 0.785. 0.785. I look at that digit, that tells me what to do there. My area is approximately 0.79 meters square when rounded to the nearest hundredth place. Number 19, I need to find the arc length. Keep in mind, arc measures are in degree, arc length is a linear measure, so it's measured in feet, inches, yards, meters, centimeters. My formula is the length is 2 pi r. Basically, it's the circumference formula multiplied by the number of degrees divided by the entire circle. So m over 360. So let's plug in what we know. My radius is 18. 2 times 18 is 36. So I'm going to say 36 pi. And then I'm going to plug in m. M is 160 degrees over 360 degrees. All right, I'm going to be fancy. I'm going to say that 36 reduces with this 360 and leaves 10. All right, and then I'm going to say that 160 reduces with 10 and leaves 16. You can go to your calculator and type all that stuff in, but basically what you're going to be left with is 16 pi. It wants me to leave my answers in terms of pi and then round it to the nearest hundredth. I need to check my unit. It says that this is centimeters. So my length in terms of pi is 16 pi centimeters. My length in terms of a number to the nearest hundredth is 50.2655. 50.2655. So when I round that, I get the length is approximately 50.27 centimeters. It is a linear unit. It is not squared or cubed. We're going to come over and we're going to find the measure of arc MNP. So it's already highlighted in red for me, and it already tells me that the degree of that arc is 270. So 2 pi r over m divided by 360. Let's plug in what we know. 2 times pi times 2 feet, and 270 over 360. So this is 4 pi. This is, I'm going to reduce that to 27 over 36. And I'm thinking both of those are divisible by 3. Let's see. I'm going to cancel 4 and 36. 4 divides into 36 9 times. How about 27 over 9? Can I reduce that? I can. Actually, 27 divided by 9 is just 3. So my length is 3 pi.
Who left their personal belongings in room 200. We ask that you please go to room 200 now to claim it before the door is locked.
And then I'm going to go to my calculator and type in 3 times pi. 3 times pi gives me 9.424. and 9.24 feet. That is a linear measure. It's feet and not squared. 42. I knew I wrote the wrong thing. It's actually 9.42. Sorry. 9.42. All right, we need to find each measure. We need to find the measure of arc JL. So JL, I'm going to take the shortest distance from J to L, which is this one. That arc is subtended by the angle JNL. And JNL says that it's 82. And I can say that there's this relationship. The measure of angle JNL is 1/2 the measure of the arc JL. So I know that the angle measures 82, so 82 equals 1/2 the measure of JL. Well, if I needed to figure out what JL is, I'm going to multiply both sides by 2. This 2 cancels with this. I've managed to get the measure of JL all by itself. So the measure of JL is 82 times 2 is 164. It's an arc, so it's measured in degrees. So that's number 21. And I also need to find the measure of angle MKL. MKL. Well, the angle MKL subtends the arc that's 64 degrees. So the measure of angle MKL is equal to 1/2 the measure of the arc ML. I know that the arc ML measures 64, so 1/2 times 64 is the measure of angle MKL. So I know that MKL equals 32, and it's an angle 32 degrees. All right, we're coming down the home stretch. I need to figure out the value of X. Wants to know what X is. I look at this, and I've got this angle right here. This angle subtends. I apologize, had to close the windows because we're cutting the grass. So this angle subtends a semicircle, and we have a theorem that says if my angle subtends a semicircle, then the angle is 90 degrees. And it makes sense because the measure of this arc is 180, so it makes perfect sense. So in order to find x, I'm going to say 3x plus 12 equals 90. I'm going to subtract 12 from both sides. 3x equals 78. Divide both sides by 3. X equals 26. It is not measured in degrees. X is 26. That's your final answer. Number 24, I need to find the measure of angle RSP. RSP is this angle right here. And I look and I see that I've got 2 angles that are marked, and I'm probably going to say that they're congruent, but I need to convince myself that I'm allowed to say this. So angle RSP subtends this arc right here. Okay. And then I'm going to say, and that same arc is subtended by this angle, which means that since both of these angles share that arc, and listen, you might need to be able to regurgitate this phrase for me come test day. You might need to say, the reason why I know that I can make those things equal to each other is because they share the same arc. So I'm going to say that 5y minus 21 equals 3y plus 3 because they subtend the same arc, they share the same arc. I'm going to subtract 3y from both sides. 2y equals 24, which means y equals 12. Does it ask me what y equals? Nope. It wants to know what the measure of angle RSP is. RSP is 3 times y, which we've just determined y is 12, plus 3. 3 times 12 is 36. 36 plus 3 is 39, and that is a degree. So the measure of angle RSP is 39 degrees. And I do believe that is it for us. Thanks very much for watching, and we'll see you on test